Hello, today we're going to be starting our new unit, which is Module 13 and volume. So our essential question is, how can you use volume to solve real-world problems? Now, we are going to be focusing on volume of cylinders, which is like a can of pop, a can of Pringles, canned goods, volume of cones, which is kind of like an ice cream cone, or anything kind of like a parking cone, a cone used in PE. Then we have volume of spheres, which is any kind of balls that you use: baseball, basketball, softball. So here are the answers to the "Are you ready?" questions. You guys should know how to do this. So we're just taking, like for number 2, we just did 2 to the 5th power, which is 32. Now, one that you might have a problem with would be number 3, which would be like 1/5 to the 3rd, which you have to do 1 to the 3rd divided by 5 to the 3rd. So 1 to the 3rd is 1. 5 times 5 times 5 is 125. So that's where we get that. Number 9 through 16 is just rounding. You guys should be able to round. And number 17 through 22, order of operations. Make sure you square that 5 squared first before you do anything else. So I'll just leave this up so you can check it. Here's our reading startup. So use the check mark words. So the shape, we have a circle. The distance around that's called the circumference, which you guys should know from Pi Day. The attributes are radius and diameter, are things that you would use for a circle. And associated words would be radius and diameter. Square and rectangle, the distance around is the perimeter. Attributes are 90-degree corners, and then they have sides. And for both of them, they're the same. So you have right angles, and you have length and width. So for the understand vocabulary, a three-dimensional figure that has one vertex and one circular base is a cone. So a vertex is where all the points meet. So that point's usually on the top of your cone, right on the top. That's your vertex. Three-dimensional figure with all points the same distance from the center. That's a sphere. Think about a baseball, softball, basketball. There's a spot inside where everything around that, since it's perfectly round, is equal from every one of those. And then 3 is a three-dimensional figure that has 2 congruent circular bases. It was a cylinder. So think about like a canned good, a can of Pringles, a hockey puck, how it's 2 circles, and then you have the height. Okay, so we're going to start off with 13.1, volume of cylinders. So the volume of a cylinder. So finding volumes of cylinders is similar to finding volumes of prisms. You find the volume of both of a prism and a cylinder by multiplying the height by the area of the base. So the base of a circle is pi r squared. So it's going to be pi r squared times the height. So you should write this down. I have this included in your notes as well. That's on our class website. So for example 1, find the volume of each cylinder, round your answer to the nearest tenth. And for these in the book, they do ask you to use 3.14 for pi. I'm okay if you use 3.14 or if you just want to use pi. That's fine. But if you look here, for letter A, they give you the radius. So radius is 3, and the height is 10. So if the radius is 3, the height is 10, we're going to use our formula. Volume equals pi r squared times height. So pi is always going to be pi. So we're going to put in a 3.14. Our radius is 3, so that's why it goes right there. So 3 squared, and then our height is 10. Make sure you square your 3 first. So you're going to get 3.14 times 9 times 10. Or 3.14 times 90 is 286. For letter B, now they give you, if you've noticed here, they don't give you the radius, they give you the diameter. So you're going to actually have to divide that by 2 to get your radius. Diameter, you don't need that, but you need to find out what the radius is, which is half of that. And they kind of tell you that right here on the right. So 6.4 divided by 2, so your radius is 3.2. Your pi is 3.14, and then your height, which is this, is 13. So it would be 3.14 times radius squared, 3.2 squared, times your height, which is 13. And then you would get about 418. So if you're doing number 4 and 5, number 4 actually gives you the diameter of 10. So we can't use that diameter of 10. We actually have to use the radius of 5. So your formula should be volume equals 3.14 times 5 squared times 6. And you can solve that. This one, they do give you the radius for number 5, so you should be able to solve that one. Now, the last part of this one is just finding the volume of a cylinder in a real-world context. You're going to do the same exact thing, but they're just going to put it real-world context where it would be like a word problem. So the Longhorn Band at the University of Texas at Austin has one of the world's largest bass drums known as Big Bertha. So here's Big Bertha. So Big Bertha has a diameter of 8 feet and is 4.5 feet deep. Find the volume of the drum to the nearest tenth. Use 3.14 for pi. So it tells you what the diameter is, which is 8 feet, but we don't want to find out what the diameter is. We want to find out what the radius is. So we have to actually divide that by 2. So radius is 4. Now the height is 4.5. So we're going to use the formula. Volume equals pi times radius squared times height. So 3.14 times 4 squared times 4.5. Make sure you use your order of operations and do 4 squared first. Otherwise, you're not going to get the right answer. So that's about it for volume of a cylinder. Remember, if you have any questions, please reach out to me. Please email me or message me, and I will get back to you as soon as I can. Thanks. Have a great day.